Crude and age-adjusted mortality rate calculations can get quite complicated. Hi, I'm Dr. Sri Banerjee, epidemiologist, biostatistician, faculty member, and in this segment, I'm going to be going over just that crude and age-adjusted mortality rates. So let's go ahead and get started. First thing you want to take a look at and try to figure out is what the crude mortality rate of population A is per 1,000. So what you do is you take a look at the total number of deaths and then divide that by 12,000. And when you do so, then you have, let me actually write that down, 287 divided by 1,000, or not 1,000, divided by 12,000. And that gives you point 0.0239. And then because this says per 1,000, what you want to do is multiply this value by 1,000. And then, of course, you get 23.917. And then that's the value per 1,000. So again, 287 over 12,000, and then 0.0239 is the decimal. You multiply that by 1,000 because of the 1,000, you get 23.917. So the next thing that you want to do is try to figure out the proportion. So the main thing you want to do is age-adjusted population A using population B as the standard, and then put the answer in per 1,000. So the first step is you have to age adjust. So let's calculate the proportion of each age group in population B. So the proportion of each age group in population B, so you would have to divide 6,000 by 9,600, 3,000 by 9,600, and then 6,600 by 9,600. So let's see what that entails. So again, just to refresh your memory, I said 6,000 divided by 9,600. And so this is equal to 0.625. Then the next age group was 3,000 divided by, of course, 9,600 again. And then that gives you 0.3125. And then the next proportion is 600 divided by 9,600. And that gives you 0.0625. So again, just to review, this is what we did just now. 15 through 19 was 6,000 divided by 9,600. 20 to 24 was 3,000 divided by 9,600. And then 25 to 29 was 600 divided by 9,600. So that's where I got the proportions from. So now we're still not done. What we now need to do is calculate crude mortality rate for each population A age group. So let's take a look here, population A, and take a look individually what each of the population is showing. So 15 through 19, 40 divided by 2,000, that's the proportion of mortality rate for 15 through 19. And then 26 out of 3,000, and then 221 divided by 7,000. So let's write this down. So here is for 15 through 19, you have 40 divided by 2,000, and then 20 to 24, you have 26 over 3,000, and then 5 to 25 to 29, you have 221 divided by 7,000. So this equals to 0.02, this equals to 0.0087, and then this equals to 0.0316. So again, just like I did in the last previous number, just going into mortality rate, 40 over 2,000, 26 over 3,000, 221 over 7,000, and then 287 over, well, this is age group mortality. So now we're getting into the interesting part because now you're combining the previous steps that you worked on to answer this question. So the question is asking the age-adjusting calculations and providing the age-adjusted mortality rate for population A. So the age-adjusting calculations is actually you have to take the numbers from the previous steps and then apply it there. So here is the age-adjusted mortality rate decimals. So I'm going to try to keep this so that it is in your view while I'm calculating the other one. So there's the 6,000 divided by 9,600, and you're technically multiplying that by 40 over 2,000. So this is, if you want to do this all decimals, then 0.625 times 0.02. So that's what you get here, and then you can add the next number. And so that is 0.3125 times 0.0087, and then 0.0625 times this number, 0.036. Then you add all those numbers together, and then you get 0.0172 times 1,000. And so the final number is 17.2 divided by 1,000, because that's per 1,000. So let's kind of take a look at this conceptually, what's going on. So so first there was the crude mortality rate. Of course, that's the easy part, and then you're doing the age-adjusted mortality. So the first thing that you did is, just to refresh your memory, population B was by age group was divided 15 to 19. So this is actually what is going on here is that you're dividing up the total number by age group. So this is why this is called age-adjusted mortality, because you're actually taking the proportion, the age proportion in the population versus the mortality rate of the population. So the proportion versus the mortality rate, or multiplied by the mortality rate, basically, of each age group, gives you the age-adjusted mortality. And that is makes sense. A lot of these calculations kind of require many more adjustments. Now, so this was the crude mortality rate per age group. Um, once you know the crude mortality rate, you can age adjust according to the mortality um, of each of the population groups, and so that gives you 17.2 divided by 1,000. I hope this video on crude and adjusted rate mortality or crude and adjusted age mortality is helpful in your studies. I hope this makes sense. Thank you for listening.